But this past Sunday at Mass, we had a reading. You might recall the first reading was from the book of Job. I thought it was apt for our subject tonight. The Lord addressed Job out of the storm and said, "Who shut within doors the sea when it burst forth from the womb? When I made the clouds its garment and thick darkness its swaddling bands? When I set limits for it and fastened the bar of its door and said, Thus far shall you come, but no farther, and here shall your proud waves be stilled." The word of the Lord. Father, Son, Holy Spirit, amen. So I thought it was apt because we have in that story of Job, Job has been complaining to God about his misfortunes and has a series of questions for God. Why do bad things happen to good people? That variety. And God answers the questions of Job with his own questions. Where were you when I created everything, set limits, told the waves, come hither, no farther? And it turned out the questions of God were much more interesting than the answers Job was looking for. So with that, tonight's topic is in series of what we've been covering in the past about how the dominant cultural theme of materialism in our culture, which pervades the natural sciences, academia, our public square, that what I call the error of scientism, namely that all knowledge to be valid must be describable in mathematical, physical, empirical terms. Anything that doesn't fit that definition isn't real, isn't true knowledge. And so in class 2, we were looking at some of the issues that Aristotle addresses and some of the micro issues in physics. Tonight we're going to get a little more exciting, where we're talking about the universe as a whole. And before we move on, I just want to point out there's no class next week. We're off for the 4th of July week. So if you come here, it'll be really warm in a dark room. Or I'm sure this AC will run regardless. So this topic tonight is just on how modern physics points to causes outside of the universe, which we'll spend time on. After that, when we get back from the break, the same materialistic reduction that's been occurring in physics is applied by neuroscience in its review of humanity over the last 50 years. And guess what? Humanity, consciousness, intellect, free will are all reducible to brain states because that's the materialistic paradigm. And so what it means to be human really is the result of electrical firings in the brain, your anatomy, and that's it. So we'll deal with that issue when we get back from the break on July 9th. So moving ahead then, modern physics takes us to what I call the doorstep of God in many ways. And I took that phrasing from, it's in your bibliography, but I truly recommend to you the books of Father Robert Spitzer, who's a Jesuit who writes on physics and science, among other topics. He also writes on spiritual topics. He's often on EWTN, a very thoughtful speaker, writer, and a very holy man. And so physics takes us to the doorstep when we consider the universe writ large I'll call out 3 ways tonight. There are more, but I'll call out the 3 ways. Big Bang cosmology. I think all of you have heard of the Big Bang as the initial origin of our universe. The law of entropy sounds intimidating, but I'll explain what I mean by that and how it too points to evidence for a beginning to the universe. The impossibility of actual past-time infinity. So infinity as a concept is often used by physicists to try to get something from nothing. And we'll explain more what I mean by that. We'll then look at evidence of fine-tuning of the control knobs of the universe, the mass of an electron. If it's off by 1 part in 1,000, there's no universe. And we'll look at some other physical laws of nature that if they're off even by a minuscule amount, we wouldn't have the universe. So fine-tuning is all of these physical constants in nature are finely tuned for our universe, and we'll address that. And then we'll look at what physicists today, primarily theoretical physicists like Stephen Hawking, try to get around this very provocative notion that the universe does have a beginning, and frankly, this isn't even disputed by the theoretical physicists. And we'll see how they try to get around it. What are their objections to avoiding explanations that are theistic? So more on that as we go. So big picture, and don't worry, we won't spend too much time on this, but the accepted view of the beginning of our universe is what we call Big Bang cosmology. Sometime 13.7 billion years ago, there was an explosion from a primeval atom that exploded and inflated quickly in nanoseconds and began to expand. And for 13.7 billion years, the universe has been expanding. And we know that by measurements people take of the cosmic background radiation of the legacy light from the Big Bang that is in every direction we look with a telescope, you see this background radiation. And we know the universe is expanding the same way you know a train is approaching and leaving when it fires that whistle. You know how when the train is approaching, the pitch goes down, and then as it's leaving from you, the pitch goes back up? That's because the wavelengths are getting smaller, larger, smaller, larger. The same thing with light. You can tell through shifts, and it's called the red shift. If something that is lit is moving from you, it has a different wavelength, a different color. And as physicists measure the outer reaches of the universe, they see this background radiation and know that the universe is expanding. The Hubble telescope has shown this as well, which was one of the older telescopes launched that showed that even stars and galaxies are proceeding further and further away from an observation point. So think of a balloon being blown up and expanding. And if there was like a dot on the balloon, the more you expand, the further that dot gets away from you if you're blowing it. So think of it that way. We have the James Webb telescope that maybe some of you have read about that was launched recently that's looking at these early galaxies, if you can believe it, and how they formed. So it's fascinating stuff that we're getting views at. So Big Bang cosmology, which began to emerge in the 20th century, in the early part of the 20th century, was so suggestive of a creation event that theoretical physicists had to get busy. They had to find explanations to somehow mitigate, lessen the idea of a beginning of the universe, because it sounded a lot like Genesis. And in fact, even the expression Big Bang comes from Frederick Hoyle, who was poo-pooing the entire idea and was making light of it. If we move now to a second evidence, which is entropy. Entropy is one of these laws in physics that is probably one of the most fundamental laws in physics. And what entropy describes is, in a closed physical system, over time, you move from a highly ordered, improbable state to a more disordered, probable state over time. It is an unrelenting law. It always happens. And so the example I give here is, suppose you had a box with a partition with marbles in it, blue on one side of the partition, red on the other. That's a condition of low entropy. Entropy is a measure of disorder. So low disorder because blue is on one side, red is on the other. Now suppose you remove the partition and put it in the back of your car and drive around for a few hundred miles on a bumpy road. The marbles get mixed together, right? That's entropy. Over time, they're completely mixed up. Or if you like to play cards and someone hands you a new deck, all the suits are in the same section, 2 through an ace. You have to shuffle the deck to mix it up. And the more you shuffle, it doesn't revert back to diamonds and then hearts and then spades and then clubs, does it? It gets more randomized. That's the purpose of shuffling when you play cards. That's entropy. It's a measure of disorder of a closed physical system that becomes more disordered and probable because the more you shuffle the deck, the more probable the sequence of the cards are randomly. What's improbable is if you shuffled the deck 5 times and found the spades first in sequential order, then the clubs, and that'd be like how you got it fresh out of the plastic when you first purchased it. You'd say, that's improbable. It's also statistically impossible, almost. Virtually, they'll say. So that's entropy. A closed physical system. It's very important that it's closed, which means there's no outside influences that introduce new information, new causality. That moves from an ordered, improbable. And ordered is improbable because it won't be like that as time goes on. It gets more probable, more disorder, more entropy. Okay. So as I mentioned, entropy is a measure of disorder in a closed physical system. That's the second law of thermodynamics. One more example to make this clear. Suppose I gave you a copy of War and Peace, about 800, 900 pages. And suppose we took the pages off the binding, kept them in order, and then tossed them up into the air. Would you expect them to come down in sequential order? No, that's entropy. And the more times I toss them, the more out of order they will get. Maybe the first time we toss it, pages 1 through 30 were caught together, but the rest got a little more randomized. You can see what's going on over time. The pages get more and more out of order. That's entropy. The universe, our universe, can be thought of as a closed physical system. And so when you combine the law of entropy with the Big Bang, what you have is, at the Big Bang, you have low entropy ordered. And then over time, as the universe expands, it becomes more disordered. It becomes cooler, actually, as well. Matter gets more spread out. At the Big Bang, Stephen Hawking talks about infinite density of this initial atom, which explodes. Very ordered, improbable, and then as the universe expands, it's like that deck of cards getting shuffled over and over and over again. So this expansion implies that there was a beginning. Why? Because as we get cooler, and as our sun has maybe 5 billion years left, supposedly, we will eventually arrive at what's called heat death. All of the stars and suns in the universe will have gone through all of their fuel. And as a result, physicists, and this is not controversial what I'm presenting, by the way, over time, for our solar system, we've got 5 billion years left. And then all life as we know it is gone in our solar system. That's going to happen across the universe because there's no additional sources of energy. Now, the fact that we're not at heat death means there had to have been a beginning, not an infinite pastime. If there was an infinite pastime, then how did we get anywhere? which we'll examine in a moment. But the fact is, we are here, in effect. And so, if we did have an infinite amount of time that's already passed, we should be at heat death now then. We're not at heat death. The fact that we're still warm and able to have a sandwich and a slice of cantaloupe means we're not at heat death yet, and we haven't traversed an infinite amount of time if that was even going to be possible. So there must be a beginning to the universe. So when you combine the Big Bang cosmology with the law of entropy, a well-known physical law, there's a beginning to the universe. So keep that in mind as we keep going now. So what do we mean, or what do physicists mean by infinities? Because these come up quite often. And they're used interchangeably, unfortunately, because physicists never took philosophy classes. So there's three senses, at least, that are used. One is what we mean by God, by the way. Absolute perfection, fullness, infinite being. God's infinity means no limits, all-powerful, and his eternity. If we keep going, there's a second sense of infinity, which we're more familiar with from mathematics, which is an infinite series of numbers. Could be all of the numbers that are even, all of the prime numbers, all of the points between a line segment that's 3 feet long can be infinitely divided. I can indefinitely, I'll say, count numbers, all the prime numbers, all the even numbers. Is that an actual infinity? No, it's not. If you took a ruler, a 3-foot ruler, and said, there's an infinite number of points on this ruler, we'd say it's infinitely divisible, but that's a potential infinity, not an actual infinity. This is the old problem of the tortoise and the hare from Zeno. Can the hare catch the tortoise if the tortoise has like a 1-foot lead and the hare is faster than the tortoise? Every time the hare makes a 1-inch move, the tortoise moves 1/10 of an inch. Every time the hare moves another inch, the tortoise keeps staying ahead of the hare. And that's the Zeno paradox of being infinitely divisible prevents the rabbit from ever catching the tortoise. And so too, it's the confusion between actual infinities and potential infinities. There are potentially an infinite number of points in a 3-foot ruler, but it's not actual. So this is constantly confused. So physicists will say, well, we know there are infinities because the number of prime numbers, or even numbers or odd numbers, is infinite. It's indefinite, but it's not an actual infinity, and that's very important to make that distinction. Another commonly used device is an actual infinity through what's called an aggregating structure, like time, space, a quantum field, are infinite. And this is simply asserted because, in fact, it's still a potential infinity. You can potentially divide a finite space indefinitely, but that's not an actual infinity. So an aggregating structure like a quantum field or any other entity that Stephen Hawking will think of or thought of is just it's posited, but it's not an actual infinity. And for Aquinas, there's no such thing as a created actual infinity. There are potential infinities. The 3-foot ruler potentially has an infinite number of points. But what's another law in geometry? A point has no magnitude. So let's see some of the paradoxes of positing an actual infinity, because I just said there's no such thing except God's infinity. So physicists will use infinite past time to try to explain away a beginning to the universe, Because if we have a beginning, then we need a cause outside of nature, and we don't want to go there. So an infinite pastime cannot be, in fact, actualized, accomplished, to arrive at now. What do I mean by that? Well, as Father Spitzer says in several of his books, infinity minus 1 hour, 1 decade, 1 millennium is still infinity. So we're no closer to arriving at the present from a prior point in time, a beginning. No temporal advance from past to present. Because an infinity can't be traversed. How do you traverse that sequence to get to point B from point A? Can't be done, can it? Or if you say, well, it can be traversed. Infinity, infinite time, infinite lengths can be traversed. How? Well, infinity minus 1 has to be something achievable. Otherwise, there could be no advance. There's no temporal advance. So infinity minus 1 at least has to be achievable, because the step before the present is the minus 1. It's the stage right before now. But if infinity minus 1 is finite, because it has to be for me to get to the present, then something finite plus 1 equals infinity, which makes no sense. That's not the definition of infinity. So that's a paradox, which shows an actual infinity is nonsense. More deeply, the succession of time is an illusion, because you can't proceed from one instant to the next if there's an infinite number of intermediaries, which is another way of saying what I've been describing. What is the difference between past and present if you can't traverse the sequence because there's an infinite number of steps? It makes time almost like an illusion, or space. So in the end, this confusion by theoretical physicists on infinities, confusing potential infinities with actual infinities that only belong to God, is science fiction. Why do they subject us to this? It's to avoid, as I mentioned earlier, thinking about causality. Because as we will see, infinities are quite useful to getting around the need for a cause outside of nature to explain the existence of the universe. It's a way of getting something from nothing. So those two areas, Big Bang cosmology and entropy, and the fact that there's no such thing as infinite pastime, because we showed the paradoxes of actual infinities, indicate that there's a beginning to the universe. But it gets better for theists, and it gets worse for materialist science that is atheistic in its orientation. So fine-tuning. I put the golem in here at the bottom because I thought you might need a break from Lord of the Rings for those who... Okay. All right. So fine-tuning of the universe refers to the spectacular improbability of the constants that are in nature, that are not derived from any other law. They just are. They're just there. Like the law of gravity. The law of gravity is fundamental because it's not derived from anything else. It's fundamental. It's given. It's discovered. So the fine-tuning is how on earth something as improbable as our universe and our existence, how is that even possible if not for fine-tuning, which implies a tuner, which is, for the physicists, that's like a vampire seeing a crucifix. So what's interesting is that these constants that are finely tuned are not disputed by any theoretical physicist. They're given. So to explain the fine-tuning, theoretical physicists that are materialists have to make appeals to things like the multiverse or other interesting, sophisticated mathematics, which, don't worry, we won't get into. We'll just brush it briefly. So the search for a theory of everything that would explain all laws of physics and the multiverse in particular, as I put it for the physicists, is like Gollum searching for the ring. And the reason why the analogy is apt is because that search destroyed the Gollum, and it destroys the integrity of science when they do this as well. Because they're just making stuff up, just so stories. Let me give you two quick examples of how finely tuned our universe is. And don't worry, we're not going to talk about the mathematics at all. I put it there because we do have engineers and mathematicians in our audience, by the way. But as I mentioned before, the law of entropy is a measure of disorder over time of a closed system. Shuffling cards, tossing a book in the air and all the pages falling all over the place. Your soup getting cold when it was hot, that's all entropy. You dropping a glass of milk on the floor, the milk moves from low entropy to high, scattered all over the place. And that process never reverses. You don't see broken glass and milk on the floor all of a sudden rise back into a fully formed glass. That's entropy. That's the law of entropy. So Roger Penrose, a very famous theoretical physicist, atheist, calculated that the low entropy, the low disorder, high order of our initial conditions of our universe, he computed that to be 1 over 10 billion taken to the 123rd power. That's how improbable our universe is. Think about that for a moment. That's how finely tuned our universe is. If it's off by even one factor, there's no universe. We'd either expand too quickly and then planets wouldn't form, or laws of gravity would kick in and we'd crunch down into one heap of matter. So that's the fine-tuning of the law of entropy. The cosmological constant, initially calculated by Albert Einstein. Then he later abandoned the theory, but it was revived when our telescopes confirmed that the universe was expanding. So the cosmological constant is often associated with dark energy. What is dark energy? Dark energy is an offset to gravity. So when the Big Bang banged, you have all of this energy and matter whirling around. Why didn't it just collapse back on itself? Because gravity would pull it all back together, like you falling from a building. Well, the cosmological constant, which is a value that can be computed, is the outward force in the universe. And it's why we are slightly expanding, even as I'm speaking. The universe as a whole is slightly expanding. So the cosmological constant offsets the law and attraction of gravity to masses. The reason why you fall to the earth and the earth doesn't fall to you is because the earth is more massive than you are. So this parameter is finely tuned to 1 over 10 to the 120th power. If it's off by 1 unit, we would, weak or stronger, we would either have crunched back down into nothing seconds after the Big Bang, or the explosion would have scattered matter so widely distributed that solar systems, galaxies, planets could never form. This is not disputed by theoretical physicists. This fine-tuning, and there's 13 or 14 other of these physical constants of nature. The mass of up quarks and down quarks. The nuclear force, which binds the nucleus of an atom together. The weak force, radioactive decay. If any of these are off by a minuscule amount, there's no universe. That's what we mean by finely tuned. It's finely tuned for this universe, and it's finely tuned for life. So in the face of this data and evidence, Stephen Hawking got busy. But before that, we jump into that, the initial arguments that were made by physicists, who again didn't attend a logic class, were, well, of course we see this fine-tuning. This is observer bias. Namely, we see a universe that's finely tuned for us, since we're here to see it. And recognize the improbability of it all. But if it wasn't finely tuned, if it was like Saturn, then there'd be no one there to see the finely tuned. So this is circular. This fine-tuning argument is circular. And of course the problem is that this kind of critique confuses what I call necessary and sufficient causality. It is certainly necessary for an observer to note the fine-tuning. By definition, it's very habitable for our lives. But that's not a causal explanation. It's not sufficient. So the examples I give here is the firing squad. So suppose you've been found guilty of a capital crime, such as being within the Capitol on January 6th, like 2 miles away. I'm just kidding. And you're put against a wall, and 10 marksmen, crack shots from the Marine Corps, get out their weapons and they fire and they all miss. Would a causal explanation after you've been the blindfold taken off, you're free to go, and someone says, how did that happen? How did you survive that? And you say, well, they missed, didn't they? I mean, that's why I'm here to tell you about it. That's not a causal. It's certainly necessary. I couldn't have the conversation with you if you didn't survive, for sure. But that's not an explanation of why they all missed. Maybe they were sympathetic to you. Or another example I give here. Suppose you just are fresh out of college, you join a property casualty insurance company, and your company insures property, equipment, and buildings and warehouses, and your first day on the job, you're assigned to go to a claim is being made at a warehouse that burned to the ground, and all the goods in it, and your boss says, get to the bottom of this, please. And so you scurry out there, and the owner says, yeah, we had a fire here. You can see it's all destroyed. And you, being a smart college graduate, say, well, I know oxygen's needed. In fact, it's necessary for fires to burn, so I'm going to fill out my report. I tell the warehouse owner, we'll file your claim immediately because oxygen is the cause of the fire burning. And you get back to the office and your boss says you're fired. Why? Because you gave an explanation of the fire? Well, that's necessary. Is it sufficient? Oxygen is necessary for a fire to burn. Fires don't burn in vacuums. But did you explain the fire, especially when you have evidence of fine-tuning, of the fine-tuning of an arsonist? That's how people discover the causes of fire. So why is that basic logic that's used in business, in this case, not admissible in physics? And in fact, this argument became an embarrassment to the theoretical physicists, and so no one advances this unless they haven't been tapped on the shoulder yet and say, don't embarrass us further with this kind of argumentation. So nevertheless, there are two lines of attack of the theoretical physicists, many who have won Nobel Prizes for other work, not this, of course. One is to just eliminate the need for a beginning. and dissolve the problem. Eliminate that provocative Genesis-like beginning of the Big Bang or the laws of entropy that indicate a beginning, or the multiverse, God's gift to atheists. So let's look at the various attempts of one of the greatest theoretical physicists of the 20th century, Stephen Hawking, who's also a Nobel Prize winner, but not for this stuff. First, let's eliminate the need for a beginning. We've got to try that one first. So in A Brief History of Time, and came out in 1988, he introduced, and by the way, you might say, well, Charles, you're taking us into deep water. I mean, who's Stephen Hawking? He's probably one of the most influential, if you had to pick one of the top influential people of the 20th century, Stephen Hawking is in that top 50 list. That book sold 10 million copies in 1988. 10 million copies of physics. People are hungry for this because he's trying to give a total explanation. And it's still taught in high school, undergrad. It's in the air. No need for a creator. So let's jump in. Hawking's purpose was, as I mentioned, eliminate the need for a beginning at the Big Bang. Yeah, there was a Big Bang, but it's not the beginning. No boundaries, no beginning. So he computed and this is where some complexity gets in, which we won't go into, a spatial entity, a singularity at the Big Bang without a preferred direction. You might remember from your high school mathematics, perhaps, complex analysis and imaginary numbers. So I is the imaginary number, and it equals the square root of -1. And believe it or not, imaginary numbers, complex analysis is used in the analysis of electric circuits and negative and positive amplitudes. And so imaginary numbers, they sound imaginary, but they do have practical real-world applications. But what Hawking did is try to use that as part of the definition of the singularity of space-time to eliminate a beginning. Let's see how he did it. Quoting from Stephen Meyer, physicists and philosophers pointed out that his decision to equate time with imaginary time has no physical justification apart from its expediency in making calculations Hawking wanted to make. When Hawking substituted I, that imaginary number that equals the square root of -1, times time, he got imaginary time for the real variable time in Einstein's mathematical expression, Einstein's equations for general relativity. The resulting depiction of the geometry of space-time did not correspond to anything real in the universe. The problem with Hawking's presentation was not the mathematical techniques he used, but instead the metaphysical interpretation that he assigned to the intermediate steps in his mathematical manipulations. Indeed, the intermediate steps in his mathematical procedure produced an expression that does not describe the space-time geometry of the real universe. Instead, time, when confined to the imaginary axis of a complex plane, as it is in complex analysis, has no physical meaning. Hawking himself acknowledged as much as he explained, imaginary numbers are a mathematical construct. They don't need a physical realization. One can't have an imaginary number of oranges or an imaginary credit card bill. Thus, in his brief history of time, he candidly described his use of imaginary time as a mathematical device or trick. Only if we lived in imaginary time would we encounter no singularities, no boundary. That's so important for him, no boundary. In real time, the universe has a beginning and its singularities that form a boundary to space-time. But at that initial boundary, the laws of physics break down. So in his technical writings, as I'll mention, he doesn't make the metaphysical interpretation of no beginning, no need for a cause. But in the popular book, A Brief History of Time, both in the 1988 edition, as well as in a copy I was just reading, that came out in 1996, he ends this section on what need of a creator. That's the metaphysical interpretation of his mathematical manipulation, which he never made in the technical papers. So sounds like he was more interested in selling books than anything else. Left out the what's the need of a cause or a creator in the technical journals. But in A Brief History of Time, 88 and 96, he put that in, the metaphysical interpretation, which is, of course, ridiculous for the reasons this quote cites. In 1983, Hawking, in parallel, had also been working on how quantum theory, the study of microscopic behavior of particles, at the Big Bang, because you have this primeval atom that exploded, so maybe it's subject to the laws of quantum mechanics, because Einstein's laws of relativity break down at that primeval atom. But maybe that could explain the existence of other universes, thus making the fine-tuning of our universe not so special, not so unique. But he ran into a problem. The method of quantum theory, which has infinitely, potentially, many infinite universes, generated more improbability of finely tuned universes than the original problem he was trying to solve. So the act of trying to multiply universes infinitely actually made the problem harder. A bit like saying a monkey typing at a typewriter eventually will type out Shakespeare. It's actually the opposite. The longer they type, the more gobbledygook you get, as any software developer knows. Let's read this quote from Hartle, a colleague of Hawking. And this is how they come clean, maybe without knowing it. But, quote, in any attempt to apply quantum mechanics to the universe as a whole, the specification of the possible quantum mechanical states which the universe can occupy is of central importance. This specification determines the possible dynamical behavior of the universe. Moreover, if the uniqueness of the present universe is to find any explanation in quantum gravity, those initial conditions at the Big Bang, it can only come from a restriction on the possible states available. Who's doing the restricting? If your mechanism is so correct, why don't you just let it run? Because there is no tuner to help it run. But it generated so many different uninhabitable, undeveloped universes that Hawking and Hartle had to restrict the number of states that the mechanism could generate. Otherwise, he created a more improbable universe, our own universe. Thus, the need to restrict possible states to only consider, as they did, universes that resemble ours. That's cheating. This represents, in the more technical jargon, an infusion of information into the system from the physicists into this so-called hypothetical test or mechanism. This is ridiculous. This is like Richard Dawkins, the biologist. You might recall in one of his books, The Blind Watchmaker. God is the blind watchmaker in quotes, and ultimately you don't need the watchmaker because the watch can be assembled blindly through evolutionary forces. The example Richard Dawkins gives is the quote from Shakespeare, "Methinks it is a weasel." And then he has a random generator computer program that starts with gibberish and eventually gets to "methinks it is a weasel," after like 65 million tries. But what's his method? As soon as he gets a word that fits the sentence, he retains it. So let's say after the 5 millionth iteration, he gets the word "me." then the next iteration will always include me. But you see, that's not how nature works. In real evolution, the me might get eaten by the tiger. In real evolution, randomness is the enemy of specified information. You don't retain things because you don't know what your target sentence is. On what basis do you retain something? Oh, the answer is survival. Whatever survives retains its genetic makeup, which is true. So tell me, what is the survival advantage of composing Beethoven's symphonies versus a cockroach? Why would we ever even evolve from the lowest life forms that are highly efficient at surviving? We're the least survivable. A baby is helpless. So this is the game that goes on with these people, whether it's in physics or biology. They infuse information at the critical moments to keep the game going. It's nonsense. It's misdirection. So the final attempt of Hawking in his later works, M theory, multiverse. You see it in science fiction movies. So what's the argument? Our universe is not so special. It's one of infinitely many universes, thus the name M theory or multiverse. These universes bubble up like soap bubbles in and out of existence based upon laws of quantum mechanics fluctuations. And certainly in quantum mechanics you do have this phenomenon, which was in the handout from last class. So Hawking is trying to use the behavior of microscopic particles that we see in quantum mechanics, the wave-particle duality, and apply it back to the beginning of the universe. So with an infinite number of universes, it's inevitable that one would resemble ours. The flaw in all of this is that the laws of quantum mechanics may explain features of our universe. It might even explain the becoming of our universe. Who knows? It doesn't explain the being or the existence of our universe. It's not a causal explanation. It's just a description of potential features of our universe. Laws of physics are not causal. The law of addition of 6 plus 12 does not put $18 in your pocket. Laws are not causal, and in fact they imply what is the condition of possibility. We're still looking for the real stuff, because laws of physics just describe stuff. They don't give a causal account, as we touched on briefly in the last class. So M theory, something from nothing. It's the final evasion of physicists, and they know it's kind of on thin ice, because if you read the literature, there's a crisis brewing amongst theoretical physicists in the search for a theory of everything. Because think about it, if you have 14, 15, 16 physical laws that are constants, that are not derived from anything prior, how on earth are you going to have a theory of everything for all of the constants of nature that derives them? It's impossible. Can't do it. So the final evasion, though, is M theory for Hawking. And in his book, The Grand Design, which came out in 2014, kind of his swan song before he passed away, quote, "We will describe how M theory may offer answers to the question of creation." He's quite blunt about it. "According to M theory, ours is not the only universe. Instead, M theory predicts that a great many universes were created out of nothing. Their creation does not require the intervention of some supernatural being or God. Rather, these multiple universes arise naturally from physical law." So, as I mentioned in class 2, when we're talking about conservation of energy, where we're back to the pre-Socratics, Parmenides, all being is one, everything is energy, just in different forms, kinetic, chemical, heat. Hawking brings us back to Plato. that the forms that actually exist outside of matter and what we know are forms that are outside of the universe in some way, but have causality and govern our experience of forms of music, treeness, whatever the nature is in question, a triangle. The absolute form of triangle exists in the heavenly realm, but it is instantiated in this material realm. But the real being of it is in the heavenly realm. This is what's going on for Hawking. He finally climbs the mountain and finds the Greek philosophers on top, saying, "What took you so long?" So the old Plato made me do it. A little humor, but this is the final evasion. And so what's really going on here? What is this, the battle to overcome medieval religious bias that held science back for centuries? Is this the payoff? These bizarre speculations that have no empirical basis in reality? Is this the hard-fought enlightenment at work now? It's a joke. It's a joke. And so what are the motivations? Now we're starting to get somewhere. Quote, and this is Leonard Susskind, probably one of the great Stanford physicists of our time. His YouTube lectures on physics are fascinating. His books on quantum mechanics and physics and relativity are fantastic. Very smart individual. Quote, if for some unforeseen reason the landscape turns out to be inconsistent, maybe for mathematical reasons or because it disagrees with observation, then as things stand now, we will be in a very awkward position. Without any explanation of nature's fine-tunings, we will be hard-pressed to answer the intelligent design critics. That's Leonard Susskind. So, oh, I'm sorry. Thank you. So I was just quoting from Leonard here. Theistic lives matter, TLM. But for these folks, anything but theism. Or Richard Lewontin, a famous Harvard evolutionary biologist. Quote, our willingness to accept scientific claims that are against common sense is the key to an understanding of the real struggle between science and the supernatural. Shockingly honest here. We take the side of science in spite of the patent absurdity of some of its constructs, in spite of the tolerance of the scientific community for unsubstantiated just-so stories, because we have a prior commitment, a commitment to materialism. Moreover, that materialism is absolute, for we cannot allow a divine foot in the door. That's a false choice, actually. The choice isn't between science and the supernatural. As I put here at the bottom, the choice is between bad science, deformed materialistic science, and the full rational project, the full rational scientific project that reason, unencumbered with biases, is capable of. Energized, motivated, guided by metaphysics, which is not a book in the Bible the last time I checked. Metaphysics opens up the full range of what the human mind can know. And it implies notions of causality that make the materialists very uncomfortable. But who has the scientific attitude? Aristotle or these guys? Aristotle wasn't a Christian. So why the ignorance of Aristotle? Because he is suggestive of vertical causation. I'll use that expression. Physics considers pushing and pulling forces and matter. Those are horizontal causes, if they even allow that term. But things like final causality that we talked about, the ends built into nature, that nature acts for ends and purposes, which is the hallmark of intelligence because it's goal-directed behavior, or efficient causes that explain the being of something. Those are vertical causes, and materialist physicists have no room for those due to their bias to atheism, which is unscientific. Be open to the full range of reason, please. You think of how silly the multiverse is as a construct. Suppose you and I discovered some dinosaur bones of a Tyrannosaurus rex. One explanation is there used to be a Tyrannosaurus rex that died and left here. Another explanation is, well, there are infinitely many universes that may have had bones on them. Why would you create a just so story outside of this universe to explain the in-your-face features of this universe? One of the hallmarks of the Enlightenment is what's called the parsimony of causality. Don't create complicated explanations. The simple explanations are the best. Occam's razor, if you remember that. So why not just say there used to be a T-Rex that lived on planet Earth and we found the bones, versus some other construct that has no empirical basis, by the way. So that's what's going on here. So summing up, over the last two classes, we've seen that the naturalist worldview is inadequate because it's not scientific. It's not the full rational project that I was talking about to make sense of the core aspects of reality due to this biased, arbitrary, dreadful decision to limit its method to mechanistic materialism. As a result, there's a permanent, what I call, inadequacy of physics alone to provide an ultimate explanation. Philosophy needs physics to give content to its general findings. But physics needs philosophy to determine its scope and ensure that its methods of proceeding are logical and rational. And believe it or not, Aristotle is returning to some of these thinkers in the sciences because of this holistic idea of nature, in information theory, integrated systems, in genetics. There's something going on of the holism, the holistic unity of Aristotle's notion of nature and substance are making a comeback and provide a paradigm for many of these minority scientists to rethink their disciplines. So what I've been getting at is we embrace the fullness of reason without revelation. It's nice to have revelation. God actually spoke a personal word to us, not just left his signature in nature and creation. But apart from revelation, we can make tremendous progress toward clarifying not only what the natural sciences are capable of, but how provocative they are in pointing to causes outside of our material universe. I mentioned St. Clement of Alexandria before. He's one of these unique figures who was a pagan, imbued in Greek philosophy, and then became a Catholic, a Christian in the 2nd century, and was constantly writing, influenced by Greek philosophy, and referred to it as a third testament that points to the transcendent, the true, the good, and the beautiful that reveals itself in nature. These figures in our history, these fathers of the church, Augustine is another one of them, who came up in pagan environments. They're providing us playbooks for today on how do we evangelize the culture that hasn't stepped inside a church ever. If you start just with the catechism, you haven't prepared them. If you start with the sacraments, you haven't prepared them. For some people, not all, you have to undo the damage that's been done in our educational system and in our culture. And Greek philosophy and its modern commentators both inside the Catholic Church and outside, are very useful in critiquing the limits of materialism as an explanation, as an ultimate explanation. So with that, I've covered what I like. The last page in your deck is just a little freebie, the traditional cosmological arguments from Arabic philosophy of the 8th, 9th, 10th, 11th centuries, and one of Aquinas' arguments for the existence of God. But really the purpose of tonight's class was just to show how modern physics points to a cause outside of nature, which we call God. So with that, let's open it up for questions. There's another quote here that, so the question is, what are physicists so terrified about in regard to the concept of God? One of the quotes that I didn't include was a physicist saying, I don't even want it to be true. Because a lot of people who think of God, just someone who is no religious tradition, not particularly interested in it, there are people who think that the idea of God is a kind of competitor, that he will limit my freedom. He will put boundaries on me that are not what I want. And this is a very unfortunate view of God as competitor or as, watching me. And of course, it's inevitably tangled with the moral and spiritual life. Aristotle may not have had any co-eds either. And what I mean is that often people will say there's no God to justify a corrupt lifestyle. And so that's part of it, I suspect. This is not just a theoretical thing for these people. It's very specific and practical to them. It might confine the range of options they would like to choose. Yes, agree.
That's very interesting too.
Right, I agree. So the comment was, Charles, you're just talking about the theoretical physicists who are atheists. But there are plenty of other physicists who are theists, Christian, what have you, and that's all true. And so it's important to point that out. What I'm getting at is what's driving our cultural bus. So I grant you that a physics professor at Indiana State University might be an incredibly great Christian and so on. They do polling of this actually, of professors in academia, apart just from their voting patterns, but which are like 85, 90% Democratic, but especially in the social science and literary areas. But in physicists, in terms of the percent that are atheists, it's well over 65%. And what's interesting, though, is that new folks coming into the field are more theistic. So that's reason for hope as well, because they've kind of gone through all this and seen what a dead end this is. And they want more. And they don't have the baggage of the legacy professors that are very popular, unfortunately very influential in our public square. The self-sacrificing physics professor at a high school who is at church every morning isn't driving the cultural narrative, unfortunately. Other questions? Yes. Right. No, that's right. And there are these paradoxes that are not resolved because there's no ultimate theory coming out of physics.
I disagree with that idea that the search for unification, what you call it,
right.
theory of everything,
theory of everything, right,
is a valid pursuit. We may never solve it, but it is a valid pursuit. From history, we had Newtonian mechanics and we had electromagnetic fields, and they were at odds with each other until we had the Einstein collection of Einstein knowledge that brought us to a common unified union, which is the theory of general relativity, a unification of those two sciences.
Right, but the question always revolves around, what do you mean by everything? And so if you're talking about just the physical laws...
Quantum mechanics and
relativity, right. Yeah, but even there, if you keep it at that baseline and don't go into metaphysics, I would tend to agree with you. But it's a problem that these constants of nature, and there's probably like 15 or 20 of them, the analogy that some physicists use who are in the Christian camp of why there will never be a theory of everything, the analogy they use is, suppose we apply this to ethics, and suppose we come across a society that has specific ethical laws, like you can't charge more than 10% on a loan. You can only have 3 wives. You can only eat certain things. You can only work on such and such days. And let's say you could only pay taxes of no more than 13, 14%. And there were 10, 15, 20 laws like that. And then someone comes along and says, well, my theory of everything is treat others as you would like to be treated. And you'd say, that's a beautiful theory. How does that connect to the laws of usury in our society? Because the cosmological constant is so precise, or entropy, or the weak force, or the nuclear force, or the mass of quarks, they're so specific. There's no theory of everything that anyone can even, what would its form be, that can derive those things that are givens. We find them in nature, we discover them. But your point is valid in general. If you think about how Aristotle thought things moved. So things on earth tended to fall toward the center of the earth. Things in the heavens tend to move in perfect circles. And there might have been different gods that moved other things around. So kind of complicated. And then Newton comes along and says, no, there's really just one law that can explain all of this mythology. The inverse square law of the masses of the two objects divided by the square of their difference times the constant. That explains all motions in the universe. So physics properly done is a great simplification. The challenge, though, is what we know so much more today that is odd and seems to be ununifiable because it's so odd, so tuned, so different. But if it can make that progress, would love to see it, provided it stays in its lane. Any closing questions? Yes. So Thomism describes the school of disciples of St. Thomas, yes. Who was the greatest theologian of the Catholic Church up to this point, who lived in the 13th century. And he wrote many commentaries on Aristotle and others. He wrote commentaries on the scriptures as well. He wrote religious hymns, various things. And really the heart of Thomism is what you might call moderate realism. And what I mean by that is, like Aristotle, all our knowledge of anything starts with our senses. And then our minds take that and form concepts, conclusions. We know reality as it is in itself, and build out a physics and metaphysics out of that. And much of our Catholic theology is based off those underpinnings. The entire sacramental system is based upon the matter-form distinctions that we agonizingly went through in class 2. So the matter of baptism is water. What's the form? What makes it baptism and not bottled water? The form is the saying, I bless this water and I baptize you in the name of the Father, Son, Holy Spirit. The Eucharist. What's the matter of the Eucharist? Unleavened bread. What's the form that constitutes it to be the Eucharist, the body and blood of Christ? The words of consecration. So you can go through every sacrament is confected this way. And so you could pick other examples as well. The entire grace and nature discussion, how grace comes to us. Do we have grace by nature, or is it a property of the soul? It's a property. If you had grace by nature, you'd be God. We hear homilies often that seem to imply that we are God, but we're not. So these distinctions, so getting back to the question, so Thomism is this movement of commentators, people who translate Aquinas. There's a large, called the Leonine project of translating the text of Aquinas, of this incredible, what I call cathedral of being, meaning that God created this world, us, and leaves his mark, the way an architect leaves their mark on a building. Or that watchmaker. We're walking along the beach, you see a watch on the beach, you say, oh, it's wonderful what waves and erosion and wind can do to assemble a watch. No. We see purpose, we see design, we see form, we see matter, we see gold. These are all hallmarks of causality in nature. So this complex of creation is this theater of cause, effect, purpose, beauty, goodness in creation. So it is why the moderate part in front of realism? Because we're not materialists. We think there is spirit, immateriality in creation. And we're not talking about grace necessarily. We're talking about causality. Requires purpose, intelligence, which is not reducible to matter. So that's the moderate part of the realism. When I know a triangle, or when I know this bottle in front of me, a chunk of the bottle isn't in my brain. I'm seeing it and abstracting out from it qualities. I can talk about the plastic. How flexible is it? Is it hot or cold? I can think about bottleness, water, nourishment. So that's the project, is this radical wager with God that your created order reflects you. Just like a building reflects an architect. And not to be afraid of it. And so we have this quote at the beginning of the class that I zoom back to the beginning, that John Paul II said in one of his encyclicals, faith and reason are like two wings on which the human spirit rises in the contemplation of truth. And God has placed in the human heart a desire to know the truth. That's part of the project of Aquinas and other theologians and philosophers. In a word, to know himself, so that by knowing and loving God, men and women may also come to the fullness of truth about themselves. This is not idle curiosity. We are fully disclosed to ourselves once we embrace God. He's not a competitor, after all. In fact, he is the ground, the condition of me achieving my purpose. Not a competitor. Because spirit doesn't compete with matter, it actualizes it. Just as those words of absolution in the confessional, we take the matter of our confession and it's elevated to forgiveness with absolution. Spirit and matter together. So that's the heart of Aquinas' project. All good philosophy and theology proceeds this way. And the natural sciences have a role, without question. So we're off next week. Don't come, the room will be dark. And then we'll treat the next topic, which is how the human person today is being reduced to matter. No soul, no sex. Gender is chosen. Because if you're just a lump of clay, why not fashion it how you see fit? But if natures reveal God and purpose and design, then we're not sovereign, are we? And that, in fact, my true happiness and fulfillment lies in contemplating that order and acting on it. So that will be our next class. But to get there, we have to go through some neuroscience. I'll make it painless. And what Aristotle and Aquinas thought about the human person and knowledge. All right, we'll see everybody in 2 weeks.